Hello everyone, and thanks for watching Edupedia World videos. I am Manish Agrawal, and today we'll be starting with atomic structure, and in that we'll start with the topic of cathode rays. Alright, we'll go into the discovery of cathode rays and some of their properties. So first let's start with how cathode rays were discovered. So cathode rays were first observed in something that we call discharge tube. So what is a discharge tube? Well, this is a figure that basically illustrates how discharge tube look on a paper. Okay, so they don't actually look like this, but on paper, if you want to see, they will look something like this. You have here a tube. Okay, so this big thing, this is the tube. All right, and then so this is a tube here. Okay, this is our major part of the experiment, the discharge tube, where we'll observe the cathode rays. Okay, so this discharge tube on the two ends has two metal electrodes. Okay, so these metal electrodes, are used to conduct electricity. Right, that is why they are placed here. So the negative electrode, for now we are calling the negative electrode as cathode, okay, and the positive electrode as anode. Okay, for now just remember that they are names, cathode and anode. Later in electrochemistry you will study what exactly is cathode and what exactly is anode. For now they are just metal electrodes which we use for conduction of electricity. Alright, so ultimately for electricity to be there, we need to supply some current. So that is done over here using the battery pack. Okay, so this is a, you can say, some sort of battery pack, but it is a high voltage battery pack. Alright, and then here lastly we have a vacuum pump. So you will have some kind of valve here. Okay, a valve. Okay, a valve is nothing but VALVE. A valve is used for basically it is like a lid. Okay, so you have lid on your boxes, so it is like a lid which can be closed and open. Alright, and you have a vacuum pump here for evacuation of the gas. Okay, so if you have a tube, a discharge tube over here, it might be filled with air, okay, or it might be filled with some specific kind of gas, say hydrogen, okay, if you want it to be so. So in order to vary the pressure inside, that is the amount of gas or air inside, we use a vacuum pump. It sucks the gas out, that is, it evacuates the tube. Alright, so this is how a discharge tube looks. So discharge tube experiments, actually before the discovery of cathode rays or electrons, there were several discharge tube experiments going on, and there were several different kinds of discharge tubes. Okay, a scientist comes and designs his own kind of discharge tube and performs some experiment, and he finds out, oh, this is something cool and nice and new, so he tells the world about it. Then people learn from that, and some other scientist comes in, then modifies his discharge tube and makes a new one, and then he observes some new phenomena, and then again, oh, this is again something even newer, even cooler and even better. So then he talks about his discharge tube, and then someone else comes in. So this whole discharge tube experiments and discovery of cathode rays, it actually is not limited to one single scientist. Okay, it is a series of scientists came, worked on it. Alright, and due to their development, okay, we finally came to know about cathode rays and how they led to the discovery of electron. Okay, so now we know the basics about discharge tube experiment. You need to know this because in fact you need to know, you need to be able to draw this diagram for your examination point of view. Alright, in your exams you directly might be asked that draw the discharge tube, okay, or talk about discovery of cathode rays using a figure or diagram. Okay, so you need to know about all these things that I have mentioned over here. So now let's see how this led to the discovery of cathode rays. Okay, so okay, now I'm just going to draw a crude representation of that discharge tube you saw above. Okay, just for your understanding. Okay, so this is the discharge tube. Let's make it a little better. So this is your discharge tube. Here you have cathode, okay, and here you have anode, okay, and you have a vacuum pump here, a valve here, okay, connected to a vacuum pump to suck the gas out, okay, so that we can modulate the pressure inside. So cathode rays were finally absorbed, okay, the cathode rays were finally observed when a sufficient amount of high voltage was applied over here. Okay, initially someone started with the common voltage, say 10 volts, then someone started with 100, then 1000, but when finally some scientists came and started the experiment with 10,000 to 20,000 volts. Okay, that is when finally we were able to observe cathode rays significantly. Okay, if you keep the voltage low, you will see some kind of discharge here, some kind of luminescence, some kind of lights here, but you cannot actually figure out that they are cathode rays. They are in form of rays traveling from one end to another end. Alright, so only when such sufficient amount of voltage is applied, you see cathode rays. And another condition that you need to meet here is at pressure. Alright, the usual pressure, that is the air you are breathing now, is around 760 millimeter of mercury. Okay, 1 atmosphere pressure, that is 760 mm of Hg. This is the usual pressure that you have, okay, of air. The pressure that you require in this experiment is around 10 to the power minus 4 mm of Hg. Alright, so this is how low you have to go in order to observe cathode rays. Alright, so there were scientists already performed the experiment, but not at this much of a pressure. Okay, in fact, before cathode rays were observed, it was very difficult to achieve such low pressures. Okay, before they were only even achieving a pressure of 10 mm of Hg was considered quite a feat. Okay, that you have done something nice, but finally someone was able to evacuate the evacuate the tube to such low pressures. And at this moment, what he observed was, when pressure was so low and voltage was so high, what he observed was there were some kind of lights here, okay? Some kind of lights or flashes of light over here. Okay, so this kind of lights were observed, and the rest of the tube was in complete darkness. Okay, so you have a closed room. Okay, you have switched off the lights. Okay, you have switched off all the lights, and when you have maintained the pressure to this value and increased the voltage to this value, what you found was that the room was dark, the tube was also dark, but this part of the tube, okay, so this is the anode end, this is the anode end, so this is positive and this is negative, okay, and this is the cathode end, positive and negative. So at the anode end they saw flashes of lights. Okay, so what they did was instead of using a normal anode electrode, what they did was they used a perforated anode. Perforated means it had holes in it, basically something like this. You have an anode plate and you have holes in that. Okay, they were done purposefully. It was not like they didn't have enough money and they cannot get a better anode. Okay, they just thought that maybe it might lead to some other observation, and they saw that the intensity or the times of the number of times they got flashes increased. Okay, so ultimately, after doing a series of other experiments, what they found was there were some kind of rays traveling from here, cathode end to anode end. Alright, cathode end to anode end, and when they struck this end of the tube, okay, when they struck this end of the tube, they gave light. Why did they give light? Because this end of the tube was coated with some special kind of materials like zinc sulfide. Okay, material like zinc sulfide, or you can use, there are several other materials which you can use to observe lights. Okay, with each kind of material you might get a different colored lights. With zinc sulfide, say, you might get green light. With some other material you might get blue light, or pink light. So based on the material used, the color of lights changed, but it didn't matter, because as long as there was some material here, it always showed that there was light here, which means that there were some kind of rays or some kind of something that was going from cathode towards anode, right? Because there was no light on this side, but there was light on this side. Okay, so see what is happening over here is this whole part is dark and this part has light. Why does it has light? Why does it have light? Because of fluorescent material. Okay. Fluorescent material such as zinc sulfide, ZnS. Alright, so zinc sulfide or any other fluorescent material, they are struck by cathode rays. They give light. Why and how we will study later on in spectrum. Alright, so they knew that these rays were traveling from cathode. Okay, from the earlier experiments they could see that when the discharge actually started, it always started from here towards anode. So they knew that these rays were traveling from cathode to anode, but they didn't know the properties of these rays, what they are, what are they made up of, okay, what kind of waves or particles might be constituents of those rays. Alright, so they just called it cathode rays because they knew that they originated from cathode. Okay, they didn't understand yet how they originated and what the properties of those rays will be, so they just called them cathode rays. And they knew that when we have a zinc sulfide coated here, that is, let's say we have a zinc sulfide screen over here, then they gave a green colored glow. Okay, they gave a green colored glow. So you have to remember this part. Alright, so when you do this, you know that you have cathode rays. Now we'll see how they analyze the properties. So to analyze the properties, what they did was, first they used some kind of obstruction. Okay, let's say they took a solid object and they placed it in path of the rays. Okay, they placed it here in path of these rays. So when they placed a solid object in path of these rays, they saw that through the angle, okay, they saw that it cast a shadow, right? It's just like when you have sun rays, okay, you have sun over here, and if you placed an object over here, okay, let's say you are standing here, so when sun rays comes to you, okay, due to this you see a shadow forming over here of yourself, right? You see a shadow forming of yourself. Similarly, when these cathode rays came with an obstruction over here, they cast a shadow of that obstruction. Okay, and based on the size, angle, okay, of that shadow, scientists easily figured out that these rays were actually traveling in straight line. Okay, so they were like light rays, not sound waves. Okay, sound does not travel in straight line. That is, if you have your door closed, you can still hear someone inside the room. Okay, but if you have the door closed, you cannot actually see inside the room. Okay, you can only see from the small holes or small open areas that there is some light inside. Okay, but you cannot actually see what's going on inside, because light rays travel in straight line. So similarly, cathode rays traveled in straight line. Okay, and obviously these rays were invisible. They could only be observed at this anode end and by the obstruction placed in between, but they could not actually see the rays traveling from one end to the other. Okay, so this is one of the first property that they observed of cathode rays. So they were invisible rays traveling from cathode to anode. These rays traveled in straight line, and these rays were made up of negatively charged particles. Now this was a very important discovery. This was made by J.J. Thomson. Okay, this discovery was made by J.J. Thomson. That is why he's often in your textbooks he is credited with the discovery of cathode rays. but he didn't actually discover or observe the cathode rays. He was not the first to do that, at least, but he was the first to prove that these rays are actually made up of negatively charged particles. Right? It's quite simple to prove that, actually. Again, we'll be using a concept of physics here. In physics, we know that like charges repel and opposite charges attract. That is, if you have a positive particle here and if you have a negative particle here, you know that they will get attracted to each other. Okay, they will get attracted to each other and get pulled towards each other. Okay, but if you have a positive particle here and a negative particle here, sorry, another positive particle here, then we know that they repel each other. Okay, they repel each other. So it was quite simple. What he did was, he took the discharge tube. Okay, he took the discharge tube and he applied, okay, he applied an electric field over here, perpendicular to the tube. Perpendicular to the tube, he applied an electric field. Okay, so when cathode rays were traveling here, what he observed was these rays got deflected towards the positive side, that is the positive electrode. Okay, which means that these rays, whatever they were made up of negative charge. Okay, they were made up of negative charge. Alright, and again, another obvious thing is that these particles, these rays, are traveling from cathode towards anode. It means, in a way, they are getting repelled by cathode and getting attracted towards anode. So this only further solidifies this postulate that these rays are negatively charged. Okay, and that these rays are actually made up of particles. How do you know that? You know that because when you added an obstruction, by the behavior of those rays, you could see that they are actually made up of particles. Okay, these rays are actually made up of particles, and in fact these rays are made up of energetic particles. So in fact these rays are made up of energetic particles. That will be the next property of cathode rays, that they are made up of energetic particles. How do we know that? Well, it's quite simple actually. You again take the discharge tube, you again add an obstruction here, and a specific kind of obstruction. What you do is, you take a wheel paddle. Okay, you know a wheel paddle, you might have played with it as a kid. Okay, it rotates. Okay, it rotates when placed in specific direction, or when you want to rotate it using your hand, you can also do that. It kind of rotates like a fan. Okay, so what they did was, they placed a wheel paddle over here, and they saw that this wheel paddle starts rotating. Okay, so again from physics, you know that for the rotation of wheel paddle, okay, it must have energy, and that energy must come from somewhere. So obviously, when there were no cathode rays, the wheel paddle won't rotate. But when they had cathode rays, that is when the voltage was sufficient and pressure was low, they saw that wheel paddles starts rotating. That is when cathode rays travel, the wheel paddle rotates. When they do not, the wheel paddle doesn't rotate. So the energy for rotation comes from the rays. Okay, so the kinetic energy of cathode rays, or some kind of energy, gets transferred to the wheel paddle. Okay, hence the wheel paddle, hence the cathode rays are made up of energetic particles. And what kind of energetic particles? Negatively charged energetic particles. Okay, so that is how this discovery was made. And last and the most important point, their behavior is independent of the gas in the tube or metal in the electrode. Okay, so now this postulate actually led to the discovery of electron. See, what they observed was, they changed the gas inside. Okay, we had very low pressure, 10 to the power minus 4 mm of Hg, but still there was gas inside. Okay, it was not completely a vacuum. So instead of air, they took say hydrogen gas. Okay, similarly they changed the metal of electrode. The electrodes are made up of metal. You have several different kinds of metal, so they changed the metal. Okay. But they observed that the behavior of the cathode rays remained same. Okay, it didn't change with the change in gas or metals. This means that whatever those particles forming the cathode rays were, they were actually common to every gas or every metal known to us. Okay. So those cathode rays were actually made up of a fundamental particle. Okay. So atoms, we know that from Dalton's theory, we know that atoms of different elements are different, so their behavior, their properties will also be different. But now here we have another fundamental particle which is common to every element that we know. Okay, and the behavior of that particle is also same always, which means there was something even more fundamental than the atom. Okay, in fact there was something which was fundamental to atom itself, which led to the formation of atom itself. Okay, that is when they first thought of electron. That is when J.J. Thomson made further calculations, and we can say that he discovered electron. Okay, again there were several scientists involved in further analysis of electrons, but that is how electron first came to be known to us. Okay, so in the next session we'll go into the details of discovery of electron, mostly the properties of electron. But for now, let's just see what's happening over here. Okay, let's just see what's happening over here, how the cathode rays are formed. Cathode rays are actually formed because of two things. Alright, first we have an electrode here, a cathode electrode. Alright, first we have a cathode electrode here. So this cathode electrode, now we know from a study of electricity, now we know that electricity is actually nothing but, conduction of electricity is nothing but traveling of electrons. Alright, so now we know that these cathode rays are actually made up of electrons. Okay, so these electrons come from cathode, the metal, okay, as well as from the gas inside the tube. Okay, let's say you have hydrogen gas. Hydrogen gas, when it gets ionized, okay, when it gets ionized, okay, what happens? You are left with H positive and one electron. So upon ionization of gas inside, okay, the ionization leads to formation of electrons. That is, you have an hydrogen atom. What you do, you strike it with some other subatomic particle or atomic particle. So you strike it with such force or such energy that it knocks off an electron. It knocks off an electron, and hence we get a free electron inside the tube. And this free electron is now negatively charged, so it will get attracted to anode and it will travel towards anode. Okay, and when it strikes a fluorescent material, here we see color or lights. Okay, so this is how cathode rays are actually formed. One source can be this, the electrode, and other source is ionization of the gas. Alright, so how exactly this takes place, we'll study further during the discovery of electron in the next session. Alright, how exactly this process takes place, and we'll go into the detail of this process. Okay, so for now this is all we need to know over here, and until next time, and once again thanks for watching Edupedia World videos.